the warm-up. All right, just our exponent properties. Okay. Number 1, John, what do we have? Okay, be careful, okay? Because what are we doing with all these exponents? Right, because there's no power that you're raising it to, so you're just adding these guys. So we have negative 13 plus 10, which gives you j to the negative third, 1 over j cubed. The parentheses threw you, and I'm not really sure why the problem has it. Maybe because just the negative exponent, that's probably why. But again, you're just adding those. Yeah, Abigail. Yep. Okay, so if you had 1 over j to the 13th times j to the 10th, you would get the same thing. Okay, where it's j to the 10th over j to the 13th, and you would get that part. Okay, if that's what you meant. All right, number 2. Josh, what do we got? Excellent, good. So here you want to take care of whatever's inside parentheses first, just one suggestion, okay? Negative 2, 3, we can't reduce it, so we'll keep it like that. We subtract, c to the 0 cancels, then we have c to the 7th. Then we have to raise each piece to the negative second, okay? So negative 2 to the negative second, a to the negative second, 3 to the negative second, b to the negative second, c to the negative 14th. Now that we have negative exponents, if it's in the top, where does it go? Bottom. If it's in the bottom, where does it go? The top. So we have 3 squared, b squared, c to the 14th, negative 2 squared, and then a squared. And then we finalize 9b squared, c to the 14th, and then 4a squared. Excellent. Okay. How many of you did get 1 correct? Number 1 correct? Okay. How many of you got number 2 correct? Good. Okay. Number 3. Let's see. Lizzie, what do we have? Okay. Number 3. Gavin. Excellent. Because S and T are not the same base, so you cannot add those together. So with this exponent on the outside, we are now multiplying. 3/4 times 4/3 is 12 over 12, which gives you S. Then 1/4 times 4/3 gives you T to the 4/12, which then is T to the 1/3. Okay? Some of you might have written it as S to the cube root of T, means the same thing. Okay? But again, if you're in rational exponent form, you want to keep it in rational exponent form. Okay? Just why do one more step? All right? Any questions on 1, 2, and 3? Okay. We have 3 more in terms of solving. Okay? 4 and 5, you're just solving. Then number 6, and I'll move this up so you can see it. Number 6, you're solving, but then checking for extraneous solutions. All right, let's go through this. Number 4, Mustafa, what do we got for an answer? X equals negative 68. Awesome. So you add 2 to both sides. X plus 4 to the 1/3 equals negative 4. Then you cube it. You have x plus 4 equals negative 64. Subtract 4. X equals negative 68. Good. Yep. You could use parentheses showing that you're raising it. Okay, the whole thing is being raised to the third power. Okay, number 5. Finn, what do we got for an answer? X equals 18 is correct. Okay, we raise it to the reciprocal. Okay, then you have x minus 2 equals, how do I rewrite 8 to the 4/3 in radical form? Brian? The cube root of 8 to the 4th. We have x minus 2 equals 2 to the 4th. X minus 2 equals 16. Add 2. And you get 18. Okay? How many of you got 4 and 5 correct? Good. Awesome. Okay, number 6. Bianca, what are our 2 possible solutions before we check? -3 and 1. Which one worked? Just one. Excellent. So we square both sides. Okay. On the left-hand side, we have 2 of them. So we have x squared plus 4x plus 4 equals 2x plus 7. We subtract the 2x, subtract the 7. X squared plus 2x minus 3 equals 0. Now we're able to factor x plus 3, x minus 1. Okay. So again, 2 solutions. And you have to check both into the original equation. Okay. From where we're starting. Original. Okay. -3 does not work. Therefore, it's extraneous. Okay. Any questions on 4, 5, and 6? Okay. In the homework, or on the homework, I should say, only 3 people caught this. Only 3 people caught this. 2D. Okay, 2D. Only 3 people caught this. X to the 2/7 equals 4. Seems pretty simple, right? What are you raising both sides to? 7/2, right? So we raise both sides to the 7/2. Okay. Now, rewrite 4 to the 7/2 in radical notation. For solving, keep in mind. How would I write that as a radical? Go ahead. Oh. Square root of 4 to the 7th because we're solving. What must it include? Plus or minus. So we have plus or minus 2 to the 7th, which was plus or minus 128. Okay? And again, just be careful. Yeah. The denominator. Denominator when you do the reciprocal. Okay? So the denominator tells you if it's even or not odd. Okay? Are there any questions on page 7? Okay. Page 8. Abigail. Number 3. Okay. So number 3, okay, you should have been able to set this up. Now, I could tell you right now the majority of your errors were probably calculator related. Okay? So from here to get r cubed by itself, you would divide by 4/3 pi, right? Using your calculator. Now, in your calculators, if you did not put parentheses around 4/3, it would do 905 divided by 4 times 3 pi. So if you got 236 or whatever it was, that's why. Okay? So in your calculators, when you do 905 divided by 4/3 pi, need 2 sets of parentheses. Or take 905 times by the reciprocal 3/4 and then divide by pi. Then take the cube root. Okay? So how many of you did get that in terms of like 236, I think it was, or something like that. Okay, before you took the cube root. All right, it came down to the calculator. All right, so in our calculators, when you're doing, like if you just entered it like this, that's what you're going to get before you take the cube root. So when you do 905 divided by, and I'm crazy in terms of, oops, parentheses, get 216.05. Then you take the cube root. So what this one just did is 905 divided by 4 first, then divided by 3 pi, or did something crazy like that. Okay, so just be careful how you enter these guys in. All right. Any other questions on page 8? Yeah, Andrew. Yep. Okay. So you have 3x plus 4, 3 2/3. Okay. So you have to subtract 22 first, right? 3x plus 4/3, 43, 2/3 equals 16. Okay. Now, I have to raise it, this whole thing, to the 3/2. Right? So I have 3x plus 43. Now, if I rewrote this, that's the square root of 16 cubed, right? What's the square root of 16? 4 cubed, 64, right? But we're taking the square root of either side. So plus or minus. So we have 64 equals negative 64. Okay. You have two answers. Yep. Okay. All right. So today we are continuing with solving. Okay. So take out your notes. In page 14, which is this. We're going to be using our calculators too today, graphing calculators, so please make sure you have those out. Yep. There you go. Yep. Okay, so when you're solving equations with two radicals, the first one would be very straightforward, okay? So what do I do in this case, in example 1? Yeah, Rory. No, we don't need to put it into fractions. How do I get rid of those radicals? Huh? Stop, Charlotte. Square both sides, okay? Square both sides, right? Because we have to get rid of 1, so we have to square both sides. So we have 4x plus 1 equals x plus 10. So this is very straightforward. From here, you could solve. So minus x. So we have 3x equals 9. X equals 3. Okay? Now we need to check to make sure there's no extraneous solution. So when we plug this in, 4 times 3 is what? 12 plus 1. Okay, so one side we have the square root of 13. Now, 3 plus 10. Do we have the same number on either side? Yes. So 3 works. Okay? This one is very straightforward in terms of you're just squaring both sides. When it gets a little complicated is examples 2 and 3. Okay? example 2, right? What is the first thing that comes to mind for example 2? What would you want to do here? First thing, yeah. Square both sides. Okay, perfect. So when we square both sides, we have x plus 2. However, on the right-hand side, what do we have to do there? Yep. No, not completely. Yeah. Because these are together through subtraction, right? So we have a binomial where we have to expand out. We're not just squaring the 4, we're squaring the whole thing. Okay? Squaring the 2, I mean. So we have x plus 2. Now we're going to do FOIL. All right? So first, 2 times 2, 4. Then 2 times negative root x. Okay? Then negative root x times 2. And negative root x times negative root x. Just x. Okay. Now, a lot of you guys will skip some of these parts, okay, in terms of it, but I just expanded out for now. So we have x plus 2 equals, I'm going to combine like terms, 4 minus 4 root x plus x. Okay? Now I still have a radical showing. So I have to move the 4 and the x to the other side because I want to isolate that square root. So we subtract 4, we subtract x. So I have negative 2 equals negative 4 root x. Then what? Sam? Divide by negative 4. So I have 1/2 equals the square root of x. Then what? Yep. You would square both sides. So what does x equal? Sam? 1/4. Okay. So go ahead and check it. See if it works. Left-hand side, on the left-hand side, we have y1. On the right-hand side, we have y2. Okay? So in your calculators, let me clear this out. Okay. So go to y equals, which is above the second key. Okay? y1, you're going to enter in the square root of x plus 2. So second x squared x plus 2. The x key is below the mode key. Okay? Everyone okay? Y equals is above the second key. Okay? Then in y2, 2 minus second x squared. X is below the mode key. Okay? Everyone okay? Right? Press graph. Do you guys see these two graphs? Yes, no, maybe so. Okay. So from here, anytime we're looking for a solution in terms of graphs, we're looking for what? The point of intersection. So to find the exact value, if you go to second, trace, number 5, and press enter 3 times. X equals 0.25. Is that what we found? Yeah, we found 1/4. Okay, So this confirms your solution that you found algebraically. Okay? If there was two solutions, you would have to do the intersection twice, or in this case with decimals it won't show it, but second graph, if I was to scroll up and down, like press the up and down arrow, I could see where my red and blue are the same exact number. That's also another solution as well, which we'll see in the next one. Okay? So again, your calculator is your last resort. Okay? Because I want you to know how to find it algebraically clearly. But again, shortcut would be in the calculator. Okay? Any questions? Okay, we're going to use it in a little bit. So I want to look at example 3, which is different. Okay? Those of you that might have larger handwriting or sloppier handwriting, you might need a separate sheet of paper. Okay? All right. What is your first instinct when you see radicals on either side? Sorry, square. Okay, good. So we're going to square both sides. All right. However, on the left-hand side, we have that plus 1. So we have square root of x plus 2 plus 1 times the square root of x plus 2 plus 1 equals 3 minus x. Okay? So now we need to multiply. What's the square root of x plus 2 times the square root of x plus 2? X plus 2, good. Then we have the square root of x plus 2 times 1. Then we have 1 times the square root of x plus 2. Then 1 times 1. Okay. Do I still have everybody with me? Are we okay? Questions, comments, concerns? Right now, that's why I'm pausing. To make sure you know how I got from here to here. Yes? Okay. We're going to combine like terms. So we have x plus 2 plus 2 root x plus 2 plus 1. And I'm going one step at a time so you can see it all. Okay? 1 and 1. Okay. So then we have, x plus 3 plus 2 root x plus 2. Okay? Now, since I have the radical still there, right, I have to isolate it. I have to isolate that. So I want to subtract my x and subtract my 3 from the right-hand side. Okay? So I have 2 root x plus 2 equals negative 2x. Everyone okay? Now what do you do? Yeah? Divide by 2. So square root of x plus 2 equals negative x. Yep. Then you square again. So you have x plus 2 equals x squared. Then what do you have to do? Right? You want to get everything to one side, right? Okay? You want to keep this x squared positive. It just makes things a little bit easier. So subtract x, subtract 2 from both sides. So you have 0 equals x squared minus x minus 2. How do I factor that? Yeah. Careful. Yep. So what are the two possible solutions, Brian. 2 and negative 1. Okay? So they're possible right now until we check them to confirm which one works and which one does not. Okay? So, any questions on this huge process right now? Yep.
I was just lost. Like, when you said check, like 20 minus X. Like,
I brought this over to this side.
okay.
So I subtracted 3 minus 2x, yeah. Then I divided by the 2 to cancel out those 2's to get negative x, okay? Then I had to square again because I still have the radical, so that becomes positive x squared. Now I like to keep my x squared positive, so I moved everything to the right, okay? So now we have 2 possible, yeah, Liz? Yep. So when you expand these out, you have the square root of x plus 2 plus 1, square root of x plus 2 plus 1, okay? So here, this is like, think of binomials, right? This would be your first term that is together, okay? So square root of x plus 2 times square root of x plus 2 is just x plus 2, all right? Then you have square root of x plus 2 times 1 is square root of x plus 2. 1 times square root of x plus 2, square root of x plus 2. Then 1 times 1 is 1, okay? And then from here, this has, you know, the 1 in front. That's why you get the 2. Okay? All right, so you have 2 and negative 1. When you check them, do we have extraneous solutions anywhere? Charlotte? Which is extraneous? 2, good. 2 is our extraneous solution. So where we will see an intersection is negative 1. So try it in your calculator. Do y1, y2, and see where they intersect. Okay? So remember, this whole side is y1, this whole side is y2. Okay? Give that a try. Go into y equals. Make sure that plus 1 is on the outside of your radical. Okay. Second graph, yeah. Okay. Do you have this? Okay. So your minus sign, you had to use this, not that. Oh, and then there you go. Okay. So for graphing, right, we're all here. Then go to second trace, number 5, and enter 3 times. And you should get the negative 1. Okay. You will also see this in second graph. If you bring up the table, look at one solution was 2, right? So look at 2, x equals 2. Do my blue and red match? Are they the same answer? No, therefore that's why it's extraneous. But if you look at negative 1, are both of these the same? Yes, so that also confirms. Okay, one thing with the graphing though. Say when you're doing second trace, number 5, say if you don't see a y value, because there's going to be some cases when we get to practice where you don't see a y value. Intersection won't work. So you have to move your cursor left or right until you see a y value. Okay, does that make sense? Okay, so when we get back from lunch, okay, you guys are going to work with a partner, and I highly suggest you do, on example 4. when we get back from lunch. All right? We're going to break right there, or arguments around this. Here it is. All right, so when you're squaring both sides, the biggest mistake I saw was right here. All right, yeah. Okay, so you have 2x plus 5 equals x plus 2 plus 2 root x plus 2 plus 1 when you FOIL it out. Yes?
Like the one step I'm confused on is like when you like add the 2 root x plus 2, does it just automatically, like why does it become 2?
Because you have two of them and you're adding. So they're like terms. Like if I had 2x or x plus x, you get 2x. Exactly. Yep. So then you go through combine like terms. You have x plus 3 plus 2 root x plus 2. You subtract, get this guy on the other side. So you end up with x plus 2 equals 2 root x plus 2. Okay, everyone okay? And I think that's where everyone got to. Yeah, Tor.
Wait, why would it be like x over 2?
So we're getting there. Okay. So before this division, you had x plus 2 equals 2 times the square root of x plus 2. Okay. Then you have to divide by 2. Right, to get the radical by itself. This is one way. Some others do a different way. However, there's some issues that happen with that. So from here, when you divide by 2, don't forget it's x divided by 2 and 2 divided by 2. A lot of you wanted to cross that out, and you cannot because they're together through addition. So 1/2 x plus 1. I get the 1 from 2 divided by 2. Okay, everyone okay? Then you have to square both sides. So when you square this is 1/2 x plus 1 times 1/2 x plus 1. So 1/2 times 1/2 is 1/4 x squared. 1/2 plus 1/2 gives you x, then 1 times 1. Okay, so from there, set everything equal to 0. Well, your x's end up canceling out. So you have 1/4 x squared minus 1 equals 0. Add 1 to the other side, then multiply by 4. Get x squared equals 4. Take the square root, okay, to get plus or minus 2. The other way that I was talking about where can get you in a little bit of trouble is from this point, which I saw in some of you did. Okay, if you had x, if you had this and you decided to square from this point, you could be correct. However, when you expand this out, fine, you have to square the 2 as well if you were to do that. That's why I do not recommend this way. I want you to isolate that radical. The reason is 9 times out of the 10, we forget about squaring that 2. So you always want to isolate your radicals. Okay, yep. This, when you square this side, right, radical disappears. So then you have x plus 2. So when you FOIL it out, because it's 1/2 x plus 1 squared, so 1/2 times 1/2 is 1/4 x squared, right? Then the middle terms are 1/2 x plus 1/2 x to give you x. Okay? Plus 1. Okay? So this was on like the challenge side because there's a lot of things going on plus our fractions. Okay? But it is similar just because there was a fraction to what we did here. Okay? So you're still trying to solve it algebraically the same way. Yeah.
Okay, so when you multiply it by 4, is that just like or do you have to?
Well, because you're dividing by 1/4. So typically when you're dividing by fractions, you're multiplying by the reciprocal. That's what it means.
I don't think you're isolating.
Yep. Because you're like isolating the x squared.
Okay.
Okay? Because you want to solve. All right? How many of you did get the plus or minus 2? Okay. All right. Some mistakes I want to say happened here. Okay. I like your honesty, so thank you. Which is a common mistake to happen. Common, very common, because we're forgetting that both pieces are divided by 2, and we always forget about this for some reason. I don't know. I do it too, so it happens. Yeah. Always put the 1. So that's the same thing. X divided by 2 is just 1/2 x. Okay? All right. So this is solving both algebraically. Okay? You could check using the calculator. But for this, since there's 2 solutions, I would use the table or do the you have to expand your window into something crazy. So we are going to do, you could stay where you are if you want. We're going to do just a little recall and then use the calculator for the rest. Give it a little break. All right? So who remembers graphing square roots? Brian, you do? Okay. Okay, that's good. So where would you, if you looked at the square root of x plus 1, where would you start that graph? Careful. Okay. It's all right. It's okay. Who remembers where to start? Abigail? -1, 0. Remember, the starting point is your HK. And if it's underneath the square root, it's to the left or right. Okay? So your starting point is -1, 0. So go to -1, 0. What would be the next x value I could use to make this a perfect square? Josh? 0, 1. Excellent. What would be another x value to make that a perfect square? John? If I plug in 2 and you're just 1 off, plug in 2, 2 plus 1 is 3. Yep. 3, and then we got 2. So 3, 2. What would be one more to make that a perfect square? Yeah, right. 8, 3. Good. Good. 8, 3. All right. So this is our first graph. Now our second graph, where would I start? All right. 2, 1. Good. It's the opposite of what you see, and then 1, 2, 1. All right. What would be the first x value I could use to make that a perfect square? Josh? 3, 2. Good. Okay. And one more. You could do 1. Yep. 6, 3. Good. Okay. So here's what the graphs look like. Do they have a point in common? Grace? 3, 2. That would be your solution. So you could write it as a point, or x equals 3 as your solution. Either one. Okay? So we're going to try this one, see what it looks like in our calculator. y1, y2 again. Okay, and we're going to do some other practice too. y1, y2. So y equals, which is above the second key. X plus 1. Okay. And hit graph. All right. So if we do second trace, number 5, enter. Okay. So, see how I was able to hit enter for the first one? But the second curve, I don't have a y value, so it's not going to pick it up. So I have to move my cursor to the right until I see it. Okay, then hit enter. So our intersection is 3, 2, which is exactly what we found, okay, by hand. All right, so when you do this, if you do not see a y value, make sure you're moving your cursor until you see it. If I go into second graph to see the table and scroll up and down, you notice that x equals 3 has the same y value. Therefore, that's your intersection point. Okay? So we're going to try a few. All right? I want you guys to try right now number 1. Okay, number 1 below. Try number 1 first. Try number 1. Getting familiar with your calculator. Nope. Just do it. Nope. Just plug it in. For number 1, what did we get for our solution? You could tell me the point or x. Go ahead, real quick. 2. If you got 2, 2 or x equals 2, you are correct. Yep. Only if you don't see the y, if it's just like y equals with no numbers at the bottom, then you would have to move it.
So, the intersection, let's do it. Or,
As soon as you see it.
oh,
As soon as you see it, because it's just gonna, unless there's 2, then you would want to put it next to your intersection, but you want to make sure that there is that y value, okay? All right, so we're gonna try a few in your calculator, okay? 2 through 5, okay? 2 through 5, use your calculator, get familiar with it, help each other out, 2 through 5. All right, yeah, just 5. For number 2, what was our solution? Go ahead, look. 4. For number 2, if you got 4, 3, or x equals 4, you are correct. For number 2. For number 3, what do we got? 3. If you got e to whatever, it's close to 0. Okay? What? It's 3. 3. What happened in number 4? Never touch, no solution. All right? Number 5. 3.5 and 1.5. So x equals 3.5. No, yes, no, yes, no, yes. Okay, let's do that one. All right, y equals clear, clear. Okay. So x to the 1/3. Those of you with maybe the older calculators, so not the ones that you plug in, the ones that when you do the exponent and it shows you the little caret, you're going to need parentheses around 1/3. Those of you that have it like this, you do not. Okay? Then you have negative x plus 5. Oops. Okay? Hit graph. Okay, good. And then second trace, number 5. And there it is. Good, Grace. Okay. So, Some of you, it depends on your calculator. If you have the one that shows the caret like that, you need parentheses around it. Okay? So some of the newer ones, which a lot of you do have, and I don't think those, it did not. So you're good. Those that did will need parentheses. That's the only downfall. Okay? So, again, you know how to solve it algebraically. You know how to find them in your calculator. You guys will definitely need to know both ways. You could check it using your calculator, but I really want you to get familiar with doing these algebraically, okay? But you won't see like this one to do algebraically because I don't want you to do negative x plus 5 cubed 3 times, do it out, and then try to solve. Nonsense, okay? Just like the ones we did in class. All right, so your homework is in the blue packet, the last 2 pages. 5.3, practice 2. Also, you do have a quiz. 5.1 to 5.4. So on Tuesday, we will talk about 5.4. It's very short and sweet. You'll have the review on Tuesday, and then on Thursday, and then your quiz will be on the 4th. We're into April, next Friday. What's your birth? Whose birthday? What? Someone say birthday? No? Birthday? No. I'm hearing things, sorry. All right.